Right now there are tardigrades on the moon. But why? Was that copyright infringement? Couldn't be. There are tardigrades, water bears, or moss piglets if you're nasty, on the surface of the moon right now. How could that possibly be life on the moon? That sounds crazy. Well, back in April 11th, I believe, the Israeli aeronautics industry was trying to land the first private spacecraft on the surface of the moon. And this was from a firm that was trying to create a backup Earth, the Arch Mission Foundation. It was trying to create like a backup Earth. So it was putting interesting things on the surface of the moon in the first private lander. On this lander had 30 million pages of digitized, miniaturized text, I believe, and DNA samples, but also thousands and thousands of these little chonkers known as water bears. So what went wrong? Why would they be on the moon? Well, this spacecraft actually crashed. They thought it was going to be a lot easier than it turned out being. Landing on the moon, space is hard, and so these tardigrades ended up being smeared across the lunar surface. Now, if you're not familiar with what a tardigrade is, they are basically the toughest life form that we know of in the universe. They are extremely resistant to temperature, extremely resistant to pressure and radiation. They are the only known organism to ever survive over an extended period of time in the vacuum of space. They can survive just about anything that we can throw at them. They survived 10 days on the outside of the International Space Station, but now, thanks to a unplanned disintegration, as Elon Musk likes to call it, of a spacecraft, there are now thousands of them on the moon. What's going to happen to these water bears on the moon? Well, that's hard to say. They were, in a dehydrated state. And in this cryptobiosis, these water bears can survive for a very long time. They can slow their metabolism down to just a fraction of 1% of what it was, and so live in kind of a suspended animation-like state for 10, maybe 20, maybe 30 years. So if we could go back to the moon, there is some universe in which we could find their tiny little bodies somewhere amidst the wreckage somehow, which they're microscopic and might be impossible. Find them, bring them back to Earth, and then rehydrate them, and maybe they would spring back to life. That's probably unlikely. They're on the surface of the moon in vacuum, no atmosphere, no water, being bombarded by radiation. If they landed in a crater, they might be freezing. If they're not in a crater, and they might be being baked by the sun, but you could bring them back, and they might survive. Who knows when we'd be able to do that? Could we return to the moon in months or years or decades? I don't know when the next moon landing is going to happen, but these water bears will be there. No matter what happens to these water bears, there's something really interesting you can say given this new fact that we know of now. These water bears are the only life forms in the universe on a celestial body that we know of outside of Earth. It's kind of like the closest thing to aliens we've ever seen or done or been a part of, which is kind of amazing. And they're kind of amazing. And you're kind of amazing because you're joining me for, you're joining me for Because Science Live, the live edition of this channel where I take all of your comments, questions, corrections, and weird questions about like boards and stuff, and I try to answer them to the best of my ability. Hey, look, hey. Look, I'm not a working scientist, I'm not an expert, but I know a little bit about a lot of sciencey and pop culture-y topics. So if you have a question for me that you think I can get through or just make entertaining in some way, you can put it in the YouTube chat and we will get to it. Do not spam questions, then we will never answer them. But I have Voice of the Void Nate here and he can help us out. What's up?
What's up, Kyle?
You know, man, Friday, long hair don't care.
Just talking about some tardigrades.
Little chunky boys.
All right, from Java Monk. Is it possible to make a retractable suit like in Black Panther, Stargate SG-1, etc.?
Okay, so there's a problem here, and the and the problem is in the thickness, or the suit being too dummy thick, if you will. So if you want to have something like a nanosuit, a suit made out of nanomachines that Tony Stark or someone like a T'Challa could wear inside of a necklace or inside of Tony's heart compartment, or whatever. The problem is thickness. So if you want some kind of suit that will protect you from bludgeoning injury and bullets and laser blasts and a weird two-sided sword that wouldn't be very good tactically, you'd have to consider just how thick you want the suit to be, or how thick it needs to be. So this is not a very thick line right here. But if you measured it, maybe if, five millimeters wide and, a couple centimeters long or what have you, if you then give it some depth, which is how thick you want the suit to be, then you can start adding up material rather quickly, even if this suit that we are talking about is just perfectly drawn straight like this, and just this thin, which would be very, very thin for something like an Iron Man suit, wouldn't it? Well, even just this thin, when you add it up over the surface area of the body, the average surface area of your average human is about 2 square meters. So if we stretched, with 2 square meters, and then we multiply this by the thickness value of whatever this is, even if it's only 5 millimeters or what have you, you suddenly find that you have a lot of material. Not not like an anvil's worth of material, not super heavy, not super light, but you have so much that it probably, even if it was nanomachines, cannot fit inside of a necklace or inside of a heart compartment. The only way you're going to get something like that from a Black Panther suit or a Tony Stark suit is if you can augment this technology such that it is still effective when it is as completely thin as possible. I don't know of any suit of armor that is like that, and that's what you would need to fit inside of a small area. Even though this is high-end sci-fi technology, it still would take up space. It still matter, and so you'd have to consider that space.
From Leonard Greenland.
Hello.
Will they ever plan to build a moon station?
Oh, didn't SpaceX say they want to create some kind of moon base, and Blue Origin has plans to do that as well? Look, I don't know what the actual timeframes are for a potentially habitable moon base, but the impetus for doing so is pretty good, because you'd want to establish a base on the moon that could be a base of operations for further space operations. So getting off the surface of the planet is hard. You need an escape velocity of 11.2 kilometers per second. Escaping the moon is a little bit easier. So if you could launch off of the moon instead of the Earth, you're going to save fuel, you're going to save time, you can have resources, refueling on there, you can start mining the moon. Having a base on the moon would be very useful. I just don't know when it's going to happen. I'm timeless, but I don't know if it's even going to happen in my lifetime, because the way that just how society works, science intertangles with politics very often, and so depending on policies or an administration that wants to do something or allows private industry to do something, that would determine how quickly we're going to get a moon base. I bet someone could let Elon Musk start doing something now. And I think, didn't NASA bet him? It's like, hey, if you land on the moon by yourselves, we'll start helping you out. It was something like that. So it could happen quickly, but that's going to depend on our willingness to let it happen. We have the technology. We just got to get there. And there's a radiation. It's very complicated, but it's not crazy.
From Kyron O'Neill.
Oh, hello.
Sorry if I'm pronouncing your name wrong.
Yeah.
Would being able to alter your personal mass up or down allow you to more easily move around in higher G environments?
Interesting. So if you were able to bulk up or bulk down like the Hulk do, and create or subtract mass from nothingness, which is impossible. And don't give me this extra dimension stuff. That's just some guy, writing dialogue like, oh, that sounds sciencey. So no extra dimension stuff. But if you could add and subtract mass for nothing, would that help you out in extreme G environments? Say you were, you were in a Dragon Ball Z kind of situation, training in 200 G. Yes. So this is complicated, because what a G force increases is your weight. So it is in effect, how hard is something pulling on you, and the resistive force of you standing on the ground in between, like for the Earth, is what your weight is. So the Earth is pulling you down, You're falling towards the Earth at 9.81 meters per second every second. The Earth's surface gets in the way of this falling, and you feel the resistance as weight. If we are suddenly under 2 Gs, you would actually weigh twice as much if we put a scale underneath your feet, but you'd have the same mass. So now this is the complicated part. If you just removed mass but increased Gs, and you're still a normal human in every sense of the word, would you be able to handle G's better? Maybe. I can think, well, maybe. But if your body also had to change to lose mass, then you might be susceptible in a new way. However, as I'm speaking, I'm realizing that I think the most G-resistant organism that we know of, and forgive me, it's a single-celled organism. I don't know if it's a fungi or a bacteria or archaea or whatever, but it's single-celled, and it can withstand like hundreds of thousands of Gs. Many times, stuff that would kill us instantly. And so they are simple life that has a great resistance to G forces. And so you'd have to check on this, but I suspect it's something similar to like radiation resistance, where the simpler the life, the less that can go wrong inside of that life, the more resistant it would be to something like G-forces. You know, these tiny single-celled organisms don't have a large circulatory system that has to pump blood up, 2 meters or whatever and then back to a heart. That can lead to your death in a high G situation, not being able to pump blood up to your brain or to your heart or whatever because it's stuck in your feet. So a more simple organism, I'm suspecting, like these single-celled organisms that I am suggesting, that you can look up on Wikipedia, if you could make your body closer to that and reduce your mass, yes, G-forces wouldn't be as much of a problem. But as it stands right now, it's hard to say if you just removed mass if it would be better on you. Depends on how much weight affects your body as it is right now. I was rambling, but hey, I'm a rambling
man.
Man?
Yeah.
Lord knows.
From Himbley Thunderbottom.
We'll see.
Could an explosion? Oh, wow, I can't even say that.
Whoa, Nate.
Can
Nate, are
an
you okay?
explosion's shockwave kill you in space?
Whoa. Okay. What is a shockwave? Say we were out here among the stars with our little chonk here, little chonkyman, and we had an explosion go off. So we have the center of the bomb here. What is a shockwave? Shockwave is a pressure wave. Pressure waves emanate out in all directions in a sphere from the explosion point. But because it is a wave of pressure, and it needs some medium to travel through. Interstellar space is, space, and especially interstellar space, is not completely empty, but it is as close to empty as anything is. And so a shockwave in space is not going to be the same problem. I don't think, to answer your question bluntly, no. I don't think you'll be hit with a shockwave in space. You could think up interesting scenarios, though. So if something blew up in space, what would hit you is radiation. So infrared radiation, heat radiation, if a nuclear blast went off, gamma rays, X-rays, that kind of thing, and that can do some serious damage. Or they could be, an EMP kind of blast, electromagnetic pulse. But not the same shockwave. So you're not going to get that same devastating, blowing down house kind of effect that you've seen in nuclear test footage. But say you were 2 spaceships very close together, and the spaceship exploded. And the spaceship has an atmosphere because it has to keep its crew alive. And then I can see some situation in that if you exploded something that already had a lot of air in it, it could push that air outward. That air is going to immediately expand into the void and become very diffuse and almost nothing. But if you were close enough to a spaceship, I bet you could feel some kind of shockwave from the debris and from the atmosphere inside of that spaceship. So specifically, I think you might find a situation where you could feel some kind of blast wave. But if you had, let's say you detonated a nuclear bomb way above the surface of the moon, you wouldn't feel it. You wouldn't feel the rush of air because there is no air.
From Crying Firelight.
Okay. If
you could be half human, half animal, what animal would you want to be?
Like Well, you're not going to answer me. This is a one-way trip. Are we talking like a centaur-like situation, or are we talking like hybrid, like have like the abilities of a different animal? Because I don't know if I want to be half me, half anything else, because then I'd have like a little, just like a little lizard limb on my arm or something. But if I could be, I'll tell you this. I have a hot take on what animals that I am afraid of the most, and I think they would be the most formidable if you were to combine a human with them, and it'd be really scary. Sharks are not the scariest thing in the ocean. I don't even think they're like number 2. At the top of my list is orcas. Killer whales are terrifying. I mean, they're beautiful, intelligent, majestic animals, but they're also terrifying in that they're so smart and they have teeth and they're really big and really fast and really strong. So killer whales, you've probably seen them coordinate attacks to knock seals off of ice floes. I've heard of killer whales killing great white sharks and then only eating their livers. Scientists find the great whites just dead with a hole in their body because the killer whales know that they only need to expend energy to get the most energy-dense tissues out of the shark's body, which happens to be the liver. It's been documented that killer whales have bumped into sharks, turned them over, and intentionally caused a state of tonic immobility, where the shark kind of becomes like zombified, and they're just like playing with their food. Killer whales are scary. So I'd want to be half Kyle, half killer whale. Kyler whale. Eh?
Yeah.
Eh? Where are you?
I'm everywhere. From exploding pineapple.
You can't prove that.
What would happen to a person if all their blood turned into red wine?
What? Is this... Okay, we're going to steer clear of the obvious example here for fear of angering anybody. But if your blood turned to wine, you would die. Literally, blood alcohol content, or BAC, calculates the percentage volume or percentage mass, I forget, but it's the percentage something of ethanol in your bloodstream. And if you have enough ethanol in your bloodstream, you will die. You will go into a state of stupor where you'll be so depressed, not mentally, but your muscle function will be depressed so much that you'll stop breathing, or you'll fall asleep and then throw up in your sleep when you're trying to reject this or whatever. So, too much ethanol in your blood will kill you. What's the ethanol content? What's the BAC that leads to death? I don't know what the figure is state to state, but I am gonna go ahead and say that 5%. If you've never seen anyone with a 5% BAC, that's because they'd be dead. So, if you took the other 95% of your blood and turned it into red wine and your body was trying to metabolize this, you'd be instantly the drunkest you could possibly be and then pass off into the arms of Morpheus.
From Brett Ranger.
Oh, detective at law.
Do you ever do ninja training, and would you ever try out for American Ninja Warrior?
So Ninja Warrior specifically, I don't do American Ninja Warrior training specifically, but I do rock climb at least twice a week for the last 12 years. So I do American Ninja Warrior type stuff, and so the thing about rock climbing is that you pretty much always skip leg day. The thing about American Ninja Warrior that you don't realize is how hard it is to run and jump and land on stuff if you're not ready for it. I say all of that because I have video of me running the American Ninja Warrior course in 2017, and I did not do well because my legs were like rubber. All the holding on to stuff, rock climbing kind of stuff, it was fine, but the momentum jumping kind of stuff, I ended up completely soaked, and there's video of it, and I might release it someday. It's embarrassing. I thought I was going to do a lot. I'm pretty good at rock climbing. I got destroyed by this course. So it's embarrassing. I don't know if I'll release it. But, start a petition on change.org like one of you did to cut my hair, and maybe I'll do something.
I signed that petition.
Thank you, Nate.
From Russ W. If a water bear was
Real
the size
friend.
of a human, would it be able to move or even survive?
Oh, man. What if this was the size of my head? What if this scale was correct right here? Would it be able to move? I have no idea. It's a good question. But when you're scaling organisms up to our size, I think often you'd find more problems than not problems. The example that most people know is that if you were to scale up an insect to the size of a person, like in the Fallout universe, if you made an ant as big as a person, I think you've probably heard of the way that ants breathe. They don't breathe like we do. They breathe through holes in the sides of their body, and so they cannot get enough air, because it's based on the surface area, to get all their tissues, volumetrically speaking, all of their tissues oxygenated fast enough. They would suffocate. There are unintended consequences of scaling up or scaling down an organism. For example, again, I don't know, I'd have to do the math on this, but if you scaled a human way, way, way down to like the size of an ant, like Ant-Man, we put out a lot of radiant energy. A lot of, what's the power of our radiated energy is about 100 joules per second worth of energy. 100 watts, like a light bulb, always coming off of our bodies. And that's why, cars fog up and it gets really hot in convention centers, but no one chooses to wear any deodorant. Anyway, so if you scaled a human down, you would heat up a lot faster than you did before because you have so much less volume to heat up, and you might just boil yourself to death in your own supersuit. So there are unintended consequences of shrinking up and shrinking down and sizing up different creatures. So if you sized up a tardigrade, I would have to imagine there would be something catastrophic about its body plan that wouldn't be able to take life at this size. Would it? I don't know if it would be able to move. I don't think they have bones. It'd be hard to support 60 kilograms of chunk when you're basically just a bag of cute. And you can quote me on that. It's hard to move your chunk when you're just a bag of cute. That describes one of my cats.
Yeah, that's a new shirt. From Probably Not Gaming.
Oh yeah, prove it.
Would you ever consider eating an alien, not intelligent, but some form that could reasonably be considered like a barnyard animal?
I'm going to dodge your question, but first answer it bluntly. No, because if it's an alien completely distinct from evolution on Earth, I would guess that it has something in its body that will not work with our metabolism. Either some chemical, let's say, this probably won't work, but let's just say that this is an alien and its bloodstream is ammonia-based and you ate it. That'd be pretty bad for you. So I would not take that chance unless we did studies on it. It's like, well, I mean, it's exactly the same, and it tastes like chocolate chicken. Maybe I'd try it. But there's one other thing that we'd have to check on, and I'm going to get a little bit more serious for a second, but we learn more and more every day, every year, about possibly extending what we think of consciousness as we know it, what we think of feeling and sentience to other animals besides us. I think you and I would probably ascribe some kind of sentience, some kind of inward feeling towards us, towards chimps, gorillas, dolphins, whales, probably. But the more we learn, the more we think it's harder and harder to draw that line. Does a chicken feel things? Does a cow have emotion? Does it get sad? Does it feel pain? Does this extend all the way down to something like an octopus? There is research saying that we might extend some kind of conscious feeling, conscious thought to something like an octopus, maybe even down to something like a large insect. So in our evolving understanding of what consciousness is, it gets harder and harder to make the argument that it's totally fine to eat another creature if you're worried, if your stopping point is that they're dumb. I hear a lot of people say, I'm vegetarian, but I still eat fish because, they don't feel anything. They're just dumb. We don't know if that's the case anymore. And so if you really wanted to take a more enlightened, so to speak, position on the conscious well-being, on the well-being of other conscious or partially conscious, barely conscious creatures, it gets harder and harder to extend what you want to eat down through the food chain. So, hard to say if I'd eat an alien. You'd really have to make sure it was not being harmed in any way aside from being food. Potentially deadly food.
What if it's super spicy?
Rant over.
From John 73, John.
Why would an alien have capsaicin in it, Nate?
Can you explain the difference between power and energy in a way that even my parents can understand?
Sure, I'll try. And this whole time I've been pausing and like clearing my throat a lot. I apologize, I'm a little under the weather. Energy and power are units. So they describe something happening in nature. The easiest way I can think to put it is that energy is a measure of an object's ability to do something to something else, to do work on something else, so to speak. So if something has kinetic energy, it has some quantity that can push and pull on other things. Power is energy. The main unit of energy is the joule, which is quantifying, this ability to do work, and the units for power are just joules per second. So power is energy over time. So if something has a lot of power, it can get a lot of this ability to do work over time. So it's constantly putting out. When I say 100 watts, that means like a light bulb or you and I are radiating out energy in the form of heat energy, 100 joules every second. So energy is the ability to do work on other systems, quantifying that, and then power is doing that over time. That's all it is. Or the ability to do that over time or consistently over time. Like horsepower, it's not just some burst of energy. It is a continuous burst of energy that keeps your car going or what have you.
From Shadow Storm 9119.
I think this is the last question.
Last question.
Yeah, okay.
Have you ever experienced failure in your career? And if so, how did you get through it?
Yeah. So I won't say specifically what it is for fear of throwing anyone else who was involved with the stuff under the bus, but I've done at least one pretty high-profile thing that when I look back on it, I consider it to be a net negative. It just didn't turn out the way that I wanted or have the impact that I wanted, and I feel like it was partially my fault. But in my case, I very consciously choose not to internalize things that are out of my control. If I know at every point, if I'm trying to do my absolute best and I believe in what I'm doing, then if something happens and it turns out differently, I know that I did my best and I could not, what has happened could only have happened that way. The only way events would have happened differently is if we existed in another universe with different variables at that exact time, and that can't happen. That kind of gets at determinism and free whatever. But so I try very hard not to internalize and take personally things that are outside of my control. For things that are inside of my control, I will admit I do kind of have a character flaw where I take everything really hard and really personally. But I really care about this stuff, and I care about you all watching, so I'm just trying my best. Try your best. Don't be too hard on yourself because yourself is all you got, which is usually the thing that I say at the end of the episodes. But that's because we're at the end of the episode. Thank you so much for joining me for this week's Because Science Live. Woo! I'm sick, but the show must go on. Next week, we have a new vlog, new episode, very fascinating, more realistic episode that you all have been asking for. Another live stream. I hope to see you there. We're going to try out something a little bit new before the live stream, so tune in. Keep your devices handy a couple, let's say 30 minutes before the live stream next week. Have a wonderful rest of your weekend, and have a great time thinking about these poor little chonkers up there. It reminds me, who knows what happened to them? But take control of what happens to you. Be nice to each other, because this is all we got. Wow, that took me a long time to get there, but I got there.